Hey everyone and welcome back. So we're doing Unit 3 now, and it's one of the most important units in the curriculum, so I'm going to try and get this right. We're going to go pretty into detail. It's some simple concepts though. We're going to be talking about Boolean expressions, control flow, and compound Boolean expressions, building off of that. Here's the curriculum. Let's do it. Okay, we're hopping in here, making a new class. I'm going to call mine Unit 3, just to keep track. Let's open this up, get rid of the starter code like we always do. And now we're ready to write code. So if we want to make a Boolean, we type Boolean, give it a name. I'm going to call it my Boolean, and we can set it equal to true. We can set it equal to false. And then 0 or 1. But if you assign your Booleans with numbers, you're weird. Okay, just don't. Okay, so we have a Boolean here, but that's not a Boolean expression. A Boolean expression is just like a mathematical expression that returns a number, but a Boolean expression returns either true or false. So to demonstrate this, I'm going to make another variable, call it my other Boolean, set this equal to true. And then we'll need the main method to do logic, so public static void main. And then let's do an if statement. So if my Boolean, exclamation point, I'll explain it, my other Boolean, we're gonna do something here. So right here is the Boolean expression, and we need to make these static just so that matches up. Okay, it's happy. This here will return true if the values do not equal each other, and it will return false if they do equal each other. This is what the not operator is. So if you type an exclamation point, it's the equivalent of doing a negative sign in a mathematical expression. It will swap what would have happened. If I were checking to see if they were equal, I would do this. 2 equal signs, 1 equal sign, and the compiler thinks it's an assignment statement. We can also do compound Boolean expressions. So we can check to see if it's equal, and then put 2 vertical line characters, I don't know what they're actually called, and that's saying or. So if my Boolean equals my other Boolean, or my Boolean is not equal to my other Boolean, we've now created a useless if statement, because this will always evaluate to true now. Because we're checking, okay, are they equal or are they not equal? And if either of the sides of this expression are true, the entire expression will return true. So you can do 2 of these, and this is called the short circuit or, which means if the compiler evaluates the left side of this statement and it's true, it won't even look at this side, and it'll immediately just push it and return true. So this is decent coding practice. I was always told to use this. If you're not supposed to, and you're like some big enterprise programmer, let me know, call me out. If you do 1, it's gonna just evaluate the whole statement. I don't think you're gonna see a performance impact on your projects. Moving on. As far as compound Boolean statements go, we also have another operator that we can use just like this vertical line, and instead of the or, it's and. So we use the ampersand for that, and to do the short circuit, we just do 2 of them, and just 1 if we want the entire statement evaluated. And the difference with this is the expression will only evaluate to true if both sides of the expression are true. If this is true and this is true, return true. If either of them are false, the entire statement evaluates to false. We also have an order of operations, just like PEMDAS in math. We have not, and, or. So if you see the exclamation point, that's getting evaluated first, then the ampersands are getting evaluated, then the vertical lines. So if you're looking at a crazy compound Boolean statement, it's got all these. Oop. I broke my code. Boop. So the curriculum at the beginning of the video had a note about equivalent Boolean expressions, and I think that lesson just had to do with discussing what expressions look different at face value. I don't know what happened there, but are essentially the same. So for example, with this if statement, we're checking if my Boolean is equal to my other Boolean, but we could write an equivalent Boolean expression by slapping some not operators around, and now we're checking and returning the opposite of if they're not equal, which does check if they're equal. So it looks ugly and redundant, but those two expressions were equivalent. If you're able to think logically, this will come pretty easy. If not, you may find it helpful to look up truth tables and make your own whenever you're writing big Boolean expressions, and you'll be able to see what the output will be as you have different values for all the Booleans that you're putting into your expression. Okay, now we're going to talk about control flow, and to do this, I want us to make a miniature project. So here at the top, I want us to import, oh boy, java.util.star. This may be utils. Okay, it looks good. So here we're going to instantiate a scanner object, call it scanner equals new scanner. If you've never done this before, all this does is creates an object for us to be able to read keyboard input from the user during the terminal output. So now that we've made that, we're able to make some variables. Let's have a string called user input and just set it equal to an empty string right now. That's not happy because this needs to be capital. And then we're going to set user input. Nope, we're going to prompt the user first. System.out.println. And let's make a fake like cheat code system for a game. Super basic. So enter your cheat code. And then if you want pretty input and output, I really like to have the user's input on the same line. So I'll do print here, and then the scanner will handle wrapping over to the next line after the user inputs. So here we just set user input to scanner dot next line, and that'll just wait until the user hits the enter key, and then the main method will keep executing. And then here we're going to do our control flow. So if let's make up some fake cheat code names. So user input dot equals cheat1, and then we'll have some code here for if that happened. And then here we can keep on going with different scenarios. So we can say else, or we can say else if and get more specific. So else if, and then we need parentheses here, and say there's a cheat code for a jetpack. Open that up, and we can keep on going with else if statements as far as we want. I'm sure you get the picture. And then here we'll do an else statement for a default. Let's take this, copy that, and then here you got the first cheat or something, and then here we'll say you have a jetpack now, and then here we'll say error, invalid code. And then if you want this to be case insensitive, I always like to do this. I'll do user input dot to uppercase, I believe. That's happy. Okay. And this will just push it all the way up to uppercase. So if I were to say jetpack in lowercase, this would still work. Here, let's go ahead and compile it. Enter your cheat code. So let's try the jetpack one. You have a jetpack now. We should have made this loop. Invalid code. And then let's see if it works lowercase. So cheat one. You got the first cheat. So that is control flow. Pretty simple. We're using Boolean expressions. I mean, these aren't like big compound ones, but these are Booleans. And that's that. Now, the last thing we need to talk about is object comparison. And I'm actually doing a little bit of it here when I'm calling the dot equals method. And you can write your own override method for equals just in any class you have. So I'll do public Boolean equals, and then you do unit 3 other. And then here you would put in all of your logic to see if the variables that are important to you are equal, and then you can return true or false based on those custom values in your class. And I think that's it for the curriculum. So if there's anything else you think I missed on this unit, please let me know. Put your questions down in the comments. I'm pretty good about responding to them. And I hope to see you in Unit 4. Thank you for watching.